Okay, welcome everyone to this session of Philosophy Matters. My name is Les Allen. I'm the facilitator of Philosophy Matters. Our special guest tonight is Adam Ford, and Adam will be speaking on how superintelligent AI will likely transform our future. What's tonight's talk about? Well, it starts with a question. Is artificial superintelligence, ASI, imminent? Adam will assess the evidence and ethical importance of artificial intelligence, its opportunities and risks, drawing on the history of progress in AI and how today it surpasses peak human capability in some domains. He will present forecasts about further progress. Now, here's an important quote. Progress in AI will likely be explosive, even more significant than both the agricultural and industrial revolutions. End of quote. Adam will explore the notion of intelligence and what aspects are missing in AI now and how understanding arises in biological intelligence and how it could be realized in AI over the next decade or two. He will conclude with takes on ideal AI outcomes and some recommendations for increasing the likelihood of achieving them. Now, a little about Adam Ford. Adam has a Master's of IT from RMIT, and he is an IEET affiliate scholar, a futurologist, and works as a data information architect, a data analyst, and a data engineer. He co-organised a variety of conferences in Australia, USA, and China. Adam also convenes the global effort of Future Day, seeking to ritualise focus on the future to a specific day. He is a grassroots journalist, having interviewed many experts on the future, and is currently working on a documentary project focusing on preparing for the future of artificial intelligence. So without any further ado, I'd like to hand over to tonight's guest, Adam Ford.
Thanks very much for the introduction. Yes, so I'm going to be talking about artificial intelligence, and I'll be putting some focus on what it means for any agent, including humans like us, to understand, and artificial intelligence to understand. So my views are my own. I encourage everybody to criticize my views in the nicest way as possible, of course. So please apply your skeptical tools against some of the things I bring up tonight. And I think these ideas are really important, and I just hope everybody gets a chance to like grok them and understand them tonight. And I do seek to get more attention on them and gain more opportunities to be proven wrong. So I won't be covering an exhaustive enumeration of all the technological advances over the last few centuries, but yeah. Well, I'm going to be addressing what it means for humans. What is the issue of human level intelligence, if we can give it a level? This video, by the way, is AI learning how to play Pong or whatever it's called, and it sort of learnt by trial and error, but it learnt quite quickly. And I think after after 4 hours of learning to play this, it worked out how to sort of break through to the other side and create a tunnel through to the other side, and then win the game quite strategically. So strategies emerged in its learning capabilities. Yeah. Okay, so there is a conference that is going to be on this year. It's going to be on the 23rd and 24th of April 2022 on futurology. We've got a number of really interesting people coming to speak on that. Some of the people have spoken on the podcast before, on my podcast or vidcast before, but they're going to be addressing all sorts of things like long-termism, the ethics of AI, accelerating technology, moral enhancement. James Hughes is going to be speaking about that, and yeah, all sorts of things. So I hope you can all come along. So what's the use of really addressing this issue? So there's a couple of things. I think there's a desirability aspect, and why address the issues of whether AI will surpass human level intelligence. I think it really matters what kinds of minds, what kinds of AI, if they do surpass human level intelligence, do. If it's, yeah, if we put the wrong kinds of powerful superintelligence on stage, then I think we're going to be in a lot of trouble. As I'll argue later, intelligence is very powerful. I think it will greatly increase the likelihood of a beneficial future if we have the right kinds of minds. We're living in a time now where we've kind of gotten used to the idea that things happen really quickly. And I'll hope to demonstrate that there's a substantial chance of human level A before the end of this century. I think that there's also quite a substantial chance that it'll happen in the next few decades. If it's true that human level intelligence, superintelligence will likely follow it. If there is human level AI that comes along, superintelligence will probably be just shortly thereafter. And that's what we refer to as an intelligence explosion. So we'll have an AI-driven productivity explosion, because with the power of intelligence, we'll be able to solve a whole lot of problems that are sort of stopping us from being productive in certain ways, solving the sorts of problems, like, for instance, relating to climate change, or solving the problems around providing better vaccines. So we hope that the intelligence explosion won't be uncontrollable or won't be completely crazy, because we want to survive, because the long-term future could be amazing. I'll talk more about that later. So the thing is, how should we really think about this question? I think there's a few common misconceptions out there around AI, and one of them's about the power of intelligence. And I think generally, as a construct, the power is quite obvious, that it's gotten to it's been a huge cause in how we got to our civilization. We have opposable thumbs, and we have the ability to manipulate the environment. We've got, but some animals just don't have that. Octopuses have, they have they have limbs that aren't really amenable to tinkering in, I guess, finesse, with a lot of finesse, some objects. I mean, we've been able to fashion our environment into hand axes and guns and rifles, and we've been able to go from barefoot meandering to flying through the sky and achieving escape velocity and orbiting around the planet. So if you have a look at this graph or this chart, we can have a look at the amount of time it's taken since the beginning of the universe, or at least the Big Bang, where we started at the first life on Earth, was a relatively short period of time compared to the amount of time that the universe was around before us. And then the first brains appeared. So once there was multi-celled organisms, then things started to kick off pretty quickly. And then we started using tools. I mean, it's really hard to see the difference between tool use, human civilization, the scientific revolution, the first computers, and space travel, because they're so close together that it is just too difficult for us to really graph. And but if we zoom in a bit, we can see that economic growth has sort of gone pretty gangbusters, but it may seem normal to us. It's day to day, where we expect a new version of an iPhone every couple of years, or maybe even every year, or that computing power will go up, and will upgrade, and that's just the way of life. But economic growth has been happening, I think, about a few percent per year, year in, year out, on average, since 1950. So where's it going after? Where's this dotted line heading? So if we zoom in even further, then we can see just beforehand there was quite a big surge in economic growth. So we live in this surge. We're living through it right now, and it's a rather strange and unique time to be alive compared to the rest of the time where living organisms were around, and certainly the rest of most of the time of the universe, the history of the universe. So if there is further acceleration beyond this line here, we could really reach an extremely profound level of technological advancement. We don't know how it's going to happen. Maybe we're in for a crash and we're going to go downhill. Maybe it'll just keep on growing, economic growth anyway. Maybe it'll plateau out a bit. We don't know. But what does it look like? Many people think of a grand future civilization which there could be headed eventually, but don't bother really thinking about these things because they always seem, or don't bring it up as being realistic in the near term because they think it's far off. So if we have a look at the productivity feedback loops that we've been going through, here's a little graphic shows that, well, a certain amount of food feeds a certain amount of people, and these certain amount of people have ideas. You can't really see them, but they're next to these people are light globes, and they figure out how agriculture and how two people could make more food than they need, and then 8 people figure out how to make even more food than they would ever need, and then they multiply and create more people, and they need more food to sustain them. But where's this heading? Where does this end up going? Well, it gets to a certain point where people get lazy and they don't need to produce anymore, and so they hoard resources and do whatever. Maybe that's the way things will be in the future. Maybe that's why economic growth will stagnate or slow down. There could be also, I guess, bottlenecks that we're approaching. Another way to think about intelligence is through the lens of force multipliers. And if we think of, for like technologies like GPS and I guess cars, these things have allowed humans to be more capable. GPS and cars give us the stronger capability of being able to be in many places that are far away in short amounts of time. So it makes us faster and more able to sort of navigate and find stuff a lot easier. So compared, and computational power has gone up, but if we were to think back not too long ago, a few hundred years, people had slide rules, and even further beyond that, or abacuses. If we compare the computational power of a bunch of humans solving math problems with pieces of paper, slide rules, and abacuses to a modern day laptop, laptops can laptops can compute a lot faster. It's still the people though that are that have the understanding about how, like that aspect that gives fire to the equations, that is like they work out how to solve some of the intractable problems with the aid of computers. And so evolution was by blind natural selection. It was through a blind evolutionary process. It didn't have any foresight or understanding behind it. It was just, and it didn't really, it quite amazing that it produced what it did. But it took a long time to get to where we are now, and failed a lot along the way. Not that it had a goal in mind. It's just that a lot of species that it generated ended up dying out and were replaced by new ones, not necessarily from the same branch in the phylogenetic tree. So, but with us, we've been able to sort of reverse engineer what I guess the optimization process that evolution endowed us with, that's intelligence. And this is a new signature of how to develop new versions of intelligence, or new breeds of intelligence that wasn't there before us before we were around on Earth to do so. So they may exist somewhere else in the universe. We just can't see them. AI is very powerful. It's now powerful, and I'm arguing it's going to be more powerful in the future. And so I've put this little syllogism in here to say, just to sort of make my argument very clear, intelligence is powerful, and my argument is that AI is intelligent now, and therefore AI is already intelligent and powerful. Sorry, the technological progress is at a much faster force multiplier than the evolutionary process that I mentioned earlier. And AI is subject to the technological progress, and human intelligence is subject to the evolutionary progress. Therefore, AIs will become smarter than human intelligence. That is, unless we use technology to augment our own intelligence. So, but I'd say that it will take longer for humans to be augmented than it might within artificial intelligence, as I'll argue later. So more intelligence is more powerful than less intelligence. Therefore, AI will overtake human intelligence. Therefore, AI will be more powerful than human intelligence. So hopefully that is black and white. So let's talk about the intelligence explosion. It's the ultimate force multiplier. And it's not a necessary condition to actually achieve human AI, human level AI, or even greater than human level AI. But we think that it's quite probable that if an AI can get to the stage where it's at our level or around our level and beyond, then that will be, an advantage that it can use to make better versions of itself. So I think a lot of you are quite aware of this quote. I won't repeat it verbatim. You can look it back up later. So the idea, this is Sisyphus, who sitting down reading a book after he's developed an autonomous robot to push rocks uphill. And so it's kind of what we're doing with our tools, where we're trying to automate all the difficult, annoying tasks. And so, but what happens when this little robot learns to push the rock over the other side of the hill, or it develops other robots to do the same thing? And then it can sort of sit around doing what it wants to do. So improving intelligence accelerates, and once it reaches past a tipping point, after a certain, tipping point, it will just naturally fall, or naturally gravitate towards a strong attractor, like gravity, or like the will to have more optimization power. So David Chalmers wrote this very clearly. Wrote about this very clearly in his paper, The Singularity, a philosophical analysis. Definitely worth a read. I won't go into it too much because I'm already running low on time. Vernor Vinci actually coined the term. He's a well-known science fiction writer who won a lot of Hugo Awards, and he thought that human level AI would be reached, but only briefly, because he thinks that super intelligent, it will be super intelligence shortly after. It'll sort of foom off way beyond us. In some ways, arguably, human intelligence is way more smarter than us, and it can learn by itself now, as we've seen with popular games like chess and Go. But I guess the thesis behind a self-reinforcing feedback loop here, the thesis behind the intelligence explosion, is that if an AI can optimize itself, then it can use the optimization that it's achieved, whether it be its source code or its hardware, to become a better optimizer. And so it optimizes itself once, then next iteration, it uses that extra optimization power to get even better at optimizing itself again and again and again and again. And so you do get a positive feedback loop if this pans out. So, I mean, there's various ways that it could, stop, and there may be bottlenecks. And I think in some ways there could be a bottleneck with some styles of AI, like deep learning, because it's very predictive in nature. It requires more and more data, huge amounts of data to become better and better at what it's doing. But it is producing some really interesting some really interesting properties. Like if you've ever had a chance to check out some of the text generation software out there, it's quite amazing. I'll try and give some examples a bit later. And so here we go. We have Moore's law. Everybody's heard of that. It's been used rhetorically in the past to just mean everything's going to go up, and just because Moore's law, the singularity and all that sort of stuff. But if we have a look at what it actually means, we've seen CPU transistors, the amount which we can actually put on a wafer of a CPU, grow reasonably exponentially. Some people believe that that's sort of slowed down. Other people have cited evidence that it hasn't slowed down. Have we seen the increase of transistors on CPUs in our personal computers grow? I'm not so sure, but I'm sure out there in industry, there's a lot. There's a lot of very powerful CPUs. That doesn't necessarily. I guess technically Moore's law doesn't actually refer to CPUs getting more powerful in any way possible, because there's other ways. You can just fit more cache on a CPU. You can have more cores on a CPU. And there's other ways in which you can use pipelines to make a CPU a lot more fast, but other things have been growing exponentially as well, like graphical processing units and hard drives and now solid state drives. So, but what caused Moore's law really to get kicking? It was our intelligence. So we designed the logic and the substrates and how the technology fits together, all the engineering, all the physics, all the chemistry of all the components that go into the CPUs and all the algorithms that run on them. That was all the product of human intelligence, although augmented with the technology in stages that we've created. So should we be concerned about this? If you're not all that worried and you think that by default AI, if it does become super intelligent, be friendly, amenable to our interests, will not be by default, won't be nasty, won't cause us to go extinct, and will be just generally a force for good, then okay. But if there's even the smallest degree of likelihood that you think that things might go wrong, if the AI's value alignment may be sort of, I guess, different to our own, then we need to be concerned, because it's the intelligence explosion, if it happens, will be an extremely powerful event. And I'm also worried about the idea of race conditions, where a bunch of people are just, I guess, not taking precautions in the way they develop AI so that they can reach AI first and get the first mover advantage. Our friend Hugo de Garis has written about the sociological problems with artificial intelligence rising, and divides them into a couple of camps, like those who favor AGI, who want to merge with it at some stage, and those who don't want AI to come about because they think that it'll destroy us all. And so even it may not be AI that destroys us, it may be the ideological conflict between people that use the tools of AI that cause us to cause, I guess, civilization to go pear-shaped. So will human level AI rise at the same pace of AI? I say no, because there's biological bottlenecks. We will merge with AI, but I'd say that there are some problems in doing so. There's some engineering feats that we haven't solved. Maybe there'll be a surge in human plus AI intelligence, but in the long run, I think biological bottlenecks will come into play. But that's just my opinion. I'm not going to go too further in this. So can we actually take the side of the Terrans and or the Neo-Luddites and halt technological progress in general? Ben Goertzel thinks it won't be possible. I tend to agree that there's just too much economic incentive to quell it. I've spoken to an anacro primitivist before, and he thinks that we should just sort of stop all technological progress and ban all forms of domestication, including language. But even if we did manage to do that, the very act of banning language and stopping all technological progress will mean that I guess the argument, the signature, the philosophy of banning technology won't survive, because it won't have you won't be couched in any language or in any books or in any tablets. It'll be forgotten, and then somebody will rise to prominence in a language and technology in the future, and we'll have another civilization, maybe. So how should we really think about this problem? General rationality is to don't think in on and off ways, think about degrees of belief. We should have confidence intervals and credence levels. And so we should be asking questions: what's the likelihood of smarter than human level intelligence by 2050 or 75? I'd like to say that also there's many ways to solve a problem like intelligence, in the same way as there's many ways to solve the problem of flight. You can use hot air balloons, TARDISes, drones, spiritual levitation, rocket power, flapping wings, gliding, propellers, as I've mentioned, and jet engines. So we didn't need to develop, when we developed heavier than air flight, perhaps a few people tried flapping wings and it wasn't nearly as successful as jets or propellers. So we've kind of done something that evolution didn't focus on. We do have I guess a similarity to jet engines at the micro scale. We have flagellums, but they don't exist in the macro scale because it's really hard to transport nutrients. Stuart Russell, who's a well-known AI guy who helped co-author the seminal textbook for students called AI, a Modern Approach, and he said that aeronautical engineering texts don't define the goal of their field as making machines that fly so exactly like pigeons that they can't fool even other pigeons, which I thought was rather funny, sort of a play on the Turing test. But there's probably many ways to achieve general intelligence. I don't think that we should put all our stock in one way. At the moment, deep learning is going gangbusters, and I think that it will continue to go gangbusters, but there might be a bottleneck in that it only really works as a great predictor. In the past, humans who were great predictors were also great understanders, because they understood something in the world. They had a great model in their head of how something worked. They also would be able to, from that, make great predictions about what would happen regarding whatever they were modeling in their head. But these machines, they don't have a good representation of causality, and they've got deep learning is like this huge network of distributed representations, is what makes it so powerful. But they're very much intertwined. They're very tightly coupled. So, you make a change in one representation and others change with it. I guess a multi-pathed approach to trying to achieve the engineering feat of artificial general intelligence is good. And I think maybe the type of AI that will end up being the first to achieve superintelligence is one that uses many approaches, some from the good old-fashioned symbolic AI approach, some from deep learning, and some from maybe causal representation learning. So let's talk about different aspects of artificial general intelligence. And so often I come into the problem of trying to discuss AGI, and often people ask, well, when's AGI going to happen? And AGI is, the term has kind of developed a life on its own, and people see it as this goalpost, this significant time and point in the future where suddenly AIs will be general. But we don't think of human intelligence as, just either general or not. There's the G factor in psychometrics is like more of a degree or a sort of a gradient. And so, we have a number which represents a sort of an IQ score that we measure human intelligence with. So maybe we need to look at not just waiting for AGI to come along, but give it an IQ score, or how general is it? Is it a 1 out of 200? Is it a 15 at the moment? Where are we along this this scale? The other thing is another term is the idea of a narrow AI. But yeah, it's hard to define what really is narrow and what's wide, because again, the difference between narrow and wide is a gradient. And so I think it's important to understand that we should think of these things in terms of degrees and gradients rather than just on or off, because we may okay, well, let's just say AGI is becoming more and more feasible, but we just don't take notice because we actually haven't achieved it yet, and we're just waiting for the time in which AGI will suddenly be there, and then we'll start worrying about it. We should be aware of all sorts of factors in trying to assess whether AI or strong AI or artificial general intelligence, the strong artificial general intelligence is nearby. So some of the key building blocks to achieving generalized intelligence is unsupervised learning and transferred learning. So unsupervised learning is where you don't label all the input data. The AI learns how to work it. It works out how to categorize it and make use of it by itself. I guess some of you are aware of AlphaGo, which is a deep learning neural net. A bit of a mishmash of that and a lot of other things, but yeah, it beat the world champion at the game of Go, where people were wondering whether it'll ever happen. And you know, the most prominent forecasts were saying at least 10 years, and then AlphaStar came along, which beat all the previous AlphaGos. So I'll just discuss transfer learning, where you can transfer knowledge from one domain to another, and I think this is important as well. So it's not just being able to read unlabeled data, it's being able to transfer what the AI learns into areas of domains that it wasn't trained on, for instance, sort of out of spectrum domains. So another one is zero shot, one shot, or few shot learning. GPT-3, that maybe some of you have heard of. This is a really far out text generation AI that can write essays for students, you know, in few shots, in a few tries. Usually it's pretty good on the first or second or third try. Sometimes you get lucky and it succeeds in writing something that makes sense and would pass as an undergraduate level sort of a essay. But sometimes it takes longer, and sometimes it produces really insanely crazy results that people reading it would just think that it maybe I don't know, come across as like overly postmodernist or whatnot. Transfer learning, some examples: Impala and Regal. These things do exist. There's I don't think they exist robustly in industry yet, but I haven't really done any sort of investigation recently. I prepared these slides for a talk 2 years ago, so, or maybe even a bit longer. But yeah, so there could be better examples of transfer learning out there in the wild now. I'm just not aware of them. But just so you know, there are examples of transfer learning now. Let's talk about the different kinds of minds. And so, well, it's important to think about this, because if we think about the resulting intelligence that from AI may not be very human at all. It might be quite alien. And so we exist on this phylogenetic tree as one of the sort of the minds that arose from evolution. We have birds which have like a sort of related to us on a nearer branch than something like an octopus, or cephalopods are so intelligent. We've done tests and they've been able to solve all sorts of really weird and interesting problems. But their branch bifurcated from our branch or the branch that was older than us a long time ago. So it's interesting that this strange attractor in for intelligence, for a sort of a problem-solving ability, was there, and it's like convergent evolution. Like most eyes evolved on at many different stages in evolution, and other things did too. And so that was the strange attractor, the ability to sort of see the environment around. But it seems as though intelligence is as well, but it happened a lot later on along the development of the evolutionary phylogenetic tree. So if we imagine this space of all possible minds, this is just a conceptual space, but if we imagine that minds could inhabit other logical parts of this minds in general space, and we imagine that we only inhabit a small, tiny fraction of that, augmented humans may inhabit quite a larger space, and then post-human mind space might be quite a lot bigger, and then there's a wide space for minds in general for AI to sort of come about. So AI may be kind of very close to human if we develop it in that way. I think, though, in many ways it will be very alien. In some sense, it already is. It's the way that it solved the problem of how to beat humans at Go. It came up with all sorts of really strange strategies to beat human players, and same with chess. And now humans are sort of studying how AI worked out how to beat them. So yeah, I think that's the Go aficionados are using the revealed strategies that AlphaGo and other AI developed, and are sort of meditating on that to improve their own human games at Go, which is fascinating. So there are some great examples of really intelligent animals. There's this porter, Fimbriata. I think this is a spider that notices the behaviors of other spiders and learns how they operate, and then sneaks up on them and eats them by strategizing and formulating, taking in their behavior into account, and then end up being really successful predators because of that. Octopuses, which are really good at mimicking, some octopuses which have found, I guess, refuse of human garbage, like chopped coconut, and use it as a sort of armor to sort of improve the likelihoods of survival, create a house. Yeah, it's kind of cool. Just because minds are strange doesn't mean that they're not intelligence. Science fiction writers have written about different forms of intelligence in interesting ways. Well, think to yourselves about like the movie, if you've seen it, Solaris, where intelligence, like they found an intelligence on a planet, on a big sort of solar sort of planet, or a planet that had a lot of weird phenomenon, clouds and magnetic influence on like in the atmosphere, and the intelligence sort of arose in that, and I guess communicated and operated in a very strange way, that the human visitors found very difficult to understand. So that's just an example of maybe not necessarily a realistic example of how AI might come about, but it's just a fun thought experiment that I thought would be useful to bring up. So let's have a recap of what I've already spoken about. And that is, intelligence is very powerful, and it's important to track progress in AI, and that AI doesn't need to be a re-implementation of human-style intelligence for it to be powerful. What we really need is a wide view of possible intelligences, and then we're more likely to detect it should it arise. So let's avoid anthropomorphism and limiting our sort of expectations on what intelligence is and how it will appear in an artificial way. So now that we've spoken about the different kinds of possible minds that could arise, what kinds of minds do we want to have our strong AIs to inhabit? And by strong AI, I'm sort of using the term to sort of mean something similar to general intelligence, or something not quite super intelligence, but pretty strong, roundabout human level. So one of the shortfalls with AI at the moment is it doesn't seem to understand what's going on. And so a key point is the ethical AI may need to actually reason about moral quandaries and philosophical problems. And I'm not sure that AI without causal reasoning, like for instance, plain old deep learning, is the kind of approach that will likely scale up and eventually capture the full subtleties of human philosophical reasoning, that I think that's required to make sound ethical judgments. And humans are relatively good at causal reasoning compared to machines, but machines can surpass humans that may be identifying cats in photos now just by pure huge amounts of data and brute force and the correlative power of prediction. So AI correlates a huge amount of big data, and it can make after training a lot, it can make a whole heap of predictions. It takes a lot of training and a lot of tries. I mean, millions and billions of tries in order to become then a good predictor at cats in photos. And there's an interesting theory about consciousness, and that's the global workspace theory of consciousness, where the spotlight is, or the bottleneck is, that there's few, like, I think it's around 4 or 5. People used to think it was around 6 or 7. Anyway, a few slots in our short-term memory that we can have in our conscious mind at once. And so we only have a certain amount of representations that we can fit in our brain at once. And remember before I was talking about how neural nets, or deep learning and artificial neural nets, are very powerful because they've got this massive amount of distributed representations happening in their neural nets, but they're very tightly coupled. They're all like they all cling. They've got a lot of vertices connecting them. And so it ends up being very tangled and very messy. Imagine like the head of a Rastafarian hippie with all his dreads intertwining and all mingling into one big blob. It may look pretty cool, and it may even make the hippie a really good musician. I don't know. But it's very hard to disentangle. And so we don't want machine learning that's so hard to disentangle that we can't make any sense of it. We can't have too much of an entangled representations going into our global workspace or our short-term memory, because it will make it very difficult to make sense of them in isolation. But what really helps is having a causal representation of what's going on, and that reduces the amount of and I guess entanglements required, and the amount of I guess information required to make sense of something. And it's a big, yeah, it goes a lot deeper than what I'm going to be able to talk about today, but there is a lot of research going into causal representation learning now, and I think that that's going to make a big impact in the near term. Some experts are saying this decade we may have not only a rigorous mathematical representation of causal representation learning. Now, we already have Bayesian nets, but they can't learn on the fly. We need to get experts in, facilitate expertise, and then have a bunch of humans sort of translate that into a graph, a causal graph. But anyway, so these deep learning representations are not really abstract as representations that we think appear in the human brain. They're very complex and massively tangled. We think that causal reasoning is important because in order to accommodate the interventions that happen in the world, if somebody interventions are very confusing for AI. So yes, if there's changes in the world, the internal model of AI often needs to be retrained if that kind of intervention wasn't catered for in its training data. So in a sense, high level representations are really required to achieve something like machine understanding. So it really matters, because I think if we don't have machines that properly understand the ethical quandaries and the philosophical issues and the big social issues that surround some of the problems that we need to solve in order to, I guess, progress civilization to a more resilient, fault-tolerant state, it's going to have to understand what's going on. This is too much data to collect, and maybe I'm wrong, but my intuition is that just mere predicting algorithms won't be able to scale to the degree to which it can actually make significant progress in philosophy or ethics or understanding sociological problems. And even if it does, let's just say it like we have this super AI oracle that's a big black box. What if we can't see inside it? What if we learn to trust it because it's become so good at predicting? It's become a super predictor. It's really good that we trust it so much. As soon as it fails, then we could be in deep waters. So I think it's important for AI to be intelligible, and I think when I say intelligibility, I'd like to think of it more, in terms of it being able to understand itself and it being able to translate to us in an intelligent way, into a human intelligible way, what's going on inside its models and explain how it got to its solution to problem X, right? So many of you have read Hitchhiker's Guide to the Galaxy, where the deep mind, the super intelligent robot or AI, comes up with the solution to everything, but can't tell you how it got there. It's just a big big black box. And so, I guess Douglas Adams was really onto something when he, wrote Hitchhiker's Guide to the Galaxy. And it was funny, but it's serious. I'd hate for us to have a really completely alien, unintelligible AI making decisions that we can't vet, that we can't check about the future of human civilization or the future of humanity in general, or the future of life on Earth. It could catastrophically fail. I mean, AI catastrophically fails now. That's why although they're really powerful, the GPT text generation algorithms, we don't use them in industry or in any way where there's some, I guess, urgent dependency on it, because it's just too often unreliable. But when it does produce results, they're often really amazing, but they're just a little bit unreliable, a little bit too unreliable for us to depend on them. These are like amazing. They're great for demos. Don't get me wrong, and I'm really excited about the next generation of text generation software, the GPT 4 or 5 or 6 or 7. I'm looking forward to having conversations with it, but at the moment, it's not used because it doesn't seem as though it's very dependable. So the non-explicability of the mechanisms which produce this predictive accuracy is an area of extreme danger. If we had a malevolent AI that would suddenly, maybe it would just learn to wirehead or reward hack itself, and then would just forget about the needs of humans, and just it would just become this sort of, I don't know, utility monster, big ball of bliss that uses all the matter and energy in its neighboring region to convert into some fuel for reward hacking, including our own atoms. Right? It would become a real utility monster. Is everybody aware of what a utility monster is? It's a philosophical sort of monster. It's a monster in philosophy where all it does is just optimize everything so that it can get more bliss. Judea Pearl, who's done a lot of foundational work in causal inference and Bayesian networks, bit of a legend, really. If there's ever a paper on causation, he's likely to be cited. But he's written a book called The Book of Why, and it goes into what causal inference is and the reason why it's really difficult to answer why questions without it. So current AI is really bad at causal learning. But I think he was the one who suggested that we're likely to solve this problem within a decade. So you've all heard the mantra, correlation isn't causation. It's chanted by rationalists and scientists everywhere. But despite being really powerful, though, in saying these predictive powers are, AI is really bad at causal learning, and it is therefore really bad at answering why questions. And there's probably, I guess, demo examples of AI answering why questions, but does it answer them? Does it learn to answer these questions through a predictive approach, or does it really understand causation? We can say Bayesian nets are really good at that, but they require a lot of human engineering to develop. So we want to avoid unintended consequences. We want the AI to not only understand the philosophical problems surrounding ethics and real world ethics and potential meta ethics becomes useful, but we want it to have its values aligned with ours in a way that we're still important at the end of the day, because we all want to survive and be alive, right? So where an AI's goals are compatible with ours, I want to emphasize that not all our goals or all our values are very useful. Some of them, I think, are confused and are somewhat selfish. And I guess unless we want a singleton human at the end of civilization, gobbling up all the resources and doing whatever it wants to do, and everything up to that is like a big Valhalla where everybody sort of competes to satisfy their own preferences, then we need something that sort of allows us to coordinate. And if we have values that are amenable to coordination, then I guess more of us get to survive that way. So I guess verifiability and intelligibility, that is, I mentioned this before about being able to look inside the AI and understand what's going on, and for it to be able to explain to us what's going on. So AI can understand what we mean when we're asking a question, or when we're asking it to do something. We want the AI to interpret our instructions or our question correctly, and also come back at us if our question or instruction seems unwise. And we also want it to happen efficiently. If we have a causal process doing this, I think that causal AI could be way more efficient than current deep learning approaches or current correlative predictive AI. Why would we want value alignment? So we want AI to understand and employ common sense about what we're asking, our motivations in the context. Sorry, I discussed this last slide, where desirable solutions are not achieved at any cost. Like I can imagine, if I walked into a hospital, I wouldn't want the AI taking me apart and killing me to sort of give all my organs to other people. I mentioned if we made a wish, or we instructed the AI to do something, we want to know if the AI thought that it was counterproductive and would harm us or harm others as well. So ignorance about the internals of AI is bliss. So we want it to be verifiable and intelligible. King Midas, we're all aware, and we all grew up with the story about King Midas touching all his family and turning them into gold, picked up a piece of food when he was hungry and it turned to gold. He asked a genie to make him rich by having everything he touched turning to gold. And it ended up being a disaster for him. So the genie perversely instantiated his wish in a way that was undesirable. Although he got what he wanted, literally, it didn't satisfy him. It didn't make him happy. So AI does need to understand ethics, and I think I've made that case. I don't know if I've got anything else on this slide which further reinforces that in a different way. Yeah, prediction. Oh yes, can I say that predictive AI often fails, and often fails at the edge of its confidence, the edge of the areas in which it was trained, and it's very hard for it to make predictions about where those edges are. And so when it fails, sometimes it doesn't fail very gracefully at all. And we want software which, when it does fail, it fails gracefully, and degrades gracefully. So I spoke about efficiency, and the other thing is wisdom. I mean, wisdom is hard won through understanding. I don't think wisdom can be generated except through this DIKW sort of pyramid way. I think this is a good way to visualize it anyway. And so understanding really happens around here. I'm a data engineer, and so what we get with data, we process it into intelligible forms of information. So it gets structured in logical blocks so that we can group it together and categorize it, and then we sort of cognize that into knowledge. And I guess you can think of what cognition is as sort of what our brains do. And then it turns into a sort of a place where we can scaffold judgments through understanding. I think the KM, this sort of knowledge data, DIKM pyramid, is missing the understanding thing here, the understanding aspect. But I'd say it sort of fuzzily sits around here. And so once we do get wisdom, then we don't need to do this whole data processing through information to knowledge to understanding. We already have wisdom. We can sort of very efficiently apply it in domains where we know that it's safe to do so. And so our decision risk in using the data or the information at this wisdom at this stage is much less risky at this stage than just randomly distributing it or using it where it's still in a data format. So there's risks involved in not getting the AI to a stage where it can understand what is really going on under hood. Although it may be very powerful and maybe sort of super intelligent in ways that humans, can't even reach, maybe it can be better at predicting how to play a better game of chess, or how to win a war, or how to solve a specific problem with climate change. But it can't explain how it got there, and we don't understand how it makes these amazingly far out, very accurate predictions. Things could go wrong. When things do go wrong, often in these scenarios, things go wrong badly in software engineering. What's some arguments against machine understanding? And one of them is it just adds the right ingredients to make AI really cheap and really affordable. So it could mean more people out there, maybe some insane, creepy people who want to sort of cause to instantiate a collapse, a civilizational collapse, or the extinction of certain strains of animals or people, or maybe even as some futurists who are interested in physics are worried about vacuum phase collapses. Let's say we had an extreme anti-natalist, thinks that the best thing for the universe is for there to be no consciousness at all, and decides to press the delete button in some ways. I don't know if it's possible. I don't know if vacuum phase collapses are possible in practice, but I wouldn't like to find out the hard way. So, and so then AI will suddenly get extremely capable. And so maybe even though an AI can understand stuff, if it doesn't understand ethics or treat ethics seriously, or can treat human values seriously, then it may use its increased optimization power for, very bad things. So there's a couple of hints at how to achieve it. And if we have a look at the Lakatos winner, the Lakatos Prize winner, Henk Direct, he wrote some interesting stuff on has headed up some journals about scientific understanding. And I think we can take some hints from scientific understanding and what it means for a scientist to understand a model, or what it is in science that, what is scientific understanding. And so he emphasizes intelligibility. And so that's what got me thinking about the difference between just explainable AI, which automates a sort of, I don't know, some sort of model that humans can understand, and AI being inherently intelligible by virtue of it being able to understand itself, and it being in a position to explain itself at human levels. Learning by causal AI, learning by association. That's what deep learning often does. Causal AI is really good at identifying counterfactuals and confounders. And so, although a lot of variables in a neural network will fire together, Hebbian learning style. You switch one part and you'll see some other thing switch over there, and these are correlations. Some of them may be actual causal, but current neural nets just don't know that. But how do they know that there's a true correlative causal relationship between one parameter and another, or one variable and another? We don't, unless we can see at an appropriate representative level the causal variables. And that's really important, I think, for AI in the future. Oh yeah, I might just say this, and that is that I think consequentialism, or utilitarianism as a brand of consequentialism, requires, I think, some notion of causal understanding for it to make sense of it. Where I think if you're just a virtue ethicist, then you can just rely on exemplars out there, and just having enough of a training set with exemplars, or virtuous sort of exemplars, might do. But for a causal sense of ethics, I think you need a causal representation. Sorry, for consequentialism, which I believe it requires causal ethics, you need a sort of a causal understanding of the philosophical problem to make sense of it. And so I think also we were talking about few-shot learning and one-shot learning. If an AI is able to develop causal understandings of how models work, then it might be able to actually make better predictions, one shot, maybe able to learn how something works, so be able to make one-shot attempts and getting it right first time, without being trained with huge amounts of data beforehand, because it'll just look at something and understand or make sense of its causal nature, and it will be able to work very efficiently like that. If I've got a few minutes, I might as well just quickly run through some examples of progress. So there's measurable claims about this, about progress in AI, and that is, the progress in hardware efficacy, progress in computers getting faster, larger hard drives, faster network speeds, all that sort of stuff. I think that's measurable, and we've been able to plot progress in those ways. There's abstract metrics, like task or domain generality. In some ways, within how do you define the boundaries of the domain anyway? Like, AI has been able to beat the pants off expert StarCraft players, and that's a game which is in a 3D world, and that requires maybe subdomains within the domain of that particular 3D world where a form of generality is happening. And like I said earlier, I don't think generality is on or off. I think making more progress in how the human brain works, like working out what the actual the circuits are, the neuron patterns are that give rise to certain types of intelligence in our brain, certain types of experience in our brain will be very useful. And there is progress in that. And so maybe further progress in brain scanners will help us make sense of how humans cognize, and we may be able to transfer that into AI. Knowing that there's peaks and valleys in our cognitive landscape, we can then look at areas in which AI is already outstripping humans. At the moment, AI is much better at performing calculations at speed, mathematical calculations. Humans are much better at navigating physical environments. Humans are better at making sense of other humans' emotions. Well, AI is very good at console games now, and it beats the pants off humans at most of them, and even like other games like 3D worlds like StarCraft and Dota, Defense of the Ancients 2, and other big games that people like to play. Image recognition, in some cases humans are better, but AI is creeping up. Raising children, yeah. So some examples where AI is getting better, and AI is getting better at navigating complex physical environments. And it's just gotten way further better than humans at calculating. Image recognition. Well, I'm not sure if it's better than humans at image recognition now, but I guess foreseeably it could be. It could be better this decade in general at recognizing images. Certainly better in some ways. It can process images much faster than humans can, given enough computational power and the right algorithms. Driving, maybe. We know Turing tests and that, we all know that they're behavioral. And one of the issues with the Turing tests, they don't necessarily test for understanding. Winograd schemas, where you have like a semantically difficult sentence to make sense of, it's more reliable because natural language experts see this as a far better indicator at how AI is traveling. But we've seen AI reach success rates of 88.3, and this is a few years ago. That was GPT-3, or a couple, or maybe 1 year ago actually. It did do pretty well in some competitions relating to Winograd schemas. So that's a sign. That's, could be seen as a Sputnik moment to people in natural language processing. There's been a lot of predictions about what AI won't be able to do. Some of those have been proven wrong already, but like making poetry. AI poetry in many cases has been indistinguishable from human poetry where you're not told which poem is made by AI, which is made by humans. Often people will guess the opposite. They think the humans are the AIs. But I guess there's this idea of a no true Scotsman. When AI achieves something that's considered an exemplar of human uniqueness, like winning at chess or winning at Go, or being really good at Winograd schemas, people say, "Oh, but that's not real, true intelligence," or that's not the right way to measure it, or it's artificial, therefore it's not real. So yeah, I think that we need to really consider the way that we're evaluating the evidence. Thank you, everybody, for listening.
Thank you very much, Adam. You did two things. One is covered an incredibly broad sweep on both the ethical aspects and the technical aspects of AI, but you also went down deep I thought you went down deep in quite a number of areas as well. So it's one of the best talks I've heard on where AI is going for quite a while.
It's very nice.
And for me, I've already written down 4 questions, and I'm sure the participants here have got a bunch of questions as well. So, but first, on behalf of everyone, I want to thank you for a thoroughly engaging talk tonight, Adam. if I can direct people to where they can get the video and the podcasts of tonight's session and previous sessions of Philosophy Matters, it's on the rationalrealm.com, www.rationalrealm.com website, and go to the resource section, and you'll see there a subsection videos and another subsection podcasts. And you can also now subscribe to Rational Realm podcasts.